Assalamualaikum and good evening everyone. Thank you for joining our discussion today. We are here to discuss about the design and component selection for our co-climbing robots. For your information, based on the rubric, our target is to build a stable moving robots that can grip and drop the ping pong ball. This issue is very important to discuss because the competition has strict sizes and cost rules, which is the robot can exceed 20 by 20 by 20 centimeters and can spend more than RM50 ringgit. For the task, the robot initially start at point B and we manually activate the robot at point B and then we move it to the point A to pick up the ping pong ball. After taking the ping pong ball at point A, and then the robot will return to the point B to drop the ping pong ball into the bin. And then from the point B, the robot must move to the point C to complete the challenge. Okay, now let's begin with the body structure first. In my opinion, we should use lightweight wood, which is thin plywood for the robot's body structure. This is because lightweight wood is very strong and easy to cut into shape and still light enough for small robots. For example, we can use 3 or 4 mm plywood frames because they will screw slightly and stay stable during motor movement and do not bend easily. So this is relevant because lightweight wood is cheap and easy to find at in most hardware shops. How about you guys?
I think I need to disagree with your opinion about the wood, lightweight wood. I think better we use a 3D printed frame because it's easy to it will fit our robot easily and it have a stable, lightweight and steady because and it's cheaper because we can use our spool 3D printer to cut the budget and we can design it perfectly our robot using AutoCAD software AutoCAD.
Yeah, your idea is great, but I would like to suggest instead of me using the AutoCAD software, I would like to using the Inventor software as based on our courses. We often use the Inventor software to design the 3D objects. So the Inventor software will be more user friendly and also be more suitable for us to use.
Yeah, I do agree with your opinion.
Okay, I would like to agree to Ika's points as well, where we use the 3D printed materials as a frame of the robots. Because unlike 3D printed materials are light, where it allows the movement of the robots become a lot smoother and also more stable. As for the movement of the robots, I would like to suggest using a two-wheel drive system where it enables horizontal movement for the robots between points on the poles. What do you guys think about this?
In my opinion, I think two-wheel is not suitable to our robot because it will cause the redundancy. Like if one will sleep, other one will sleep also. So I suggest we add two more, which is will make a four-wheel.
Yeah, I also agree with Ika. I think we should use four-wheel drive system for our robots. This is because four wheels give better balance and stability. Robots will not lose balance easily and especially when moving at a straight line.
For me, I would like to agree with Sean Pass. As we're using the four-wheel system, the costing will be more higher because based on my survey online, the costing for wheels will be needed for like exactly 3 ringgit per each. So we need to consider our budget, which is not exceeded the 50 ringgit. And also, like Ika did say just now, when we using the four-wheel system, is it too heavy for the robot? Because we also need to maintain the smoothness for the robot and also avoid the robot from sleeping on the floor.
That's a good question, but I think a four-wheel drive system is more suitable for this robot because the stability is can confirm. And then for the cost, for the budget part, we can buy two wheel from in Lazada and another two wheel we can make it by using a recycled material. So we can act as like a supporting wheel for the robot. So by doing this, the budget and the stable of the robot can be confirmed.
Okay, so I think we all agree on using the four wheel system where there's we use two normal wheels and two supporting wheels that is made by recycled materials which are more lighter and more cost efficient. So as for the movement mechanism, I would like to ask if any of you have any ideas on how do we make the robot control the robot's movements.
I would suggest using a motor driver to control the movement of the robot. We can using a motor driver L298N to control the movement of the robot. By doing this, the robot can move forward and backward in the same coordinate. If not, if without a motor driver, the motor or the robot only can move in one direction. So we can using this motor driver to control the movement of the robot.
Okay, I think that is a good idea to control the movement of the robots. So what about the gripping mechanism?
For the gripping mechanism, I have an idea. How about we use a stepper motor for the claw to retrieve the ping pong ball? And for the shape, how about we use a claw shape with a parallel gripping for a more stable gripping?
Uh, I like your cross-shape idea, but I disagree with your stepper motor that part because stepper, as we know, stepper motor is very large and heavier, which will affect the stability of the robot, and it also cost higher, which not suitable for us for making the robot. I would suggest using a servo motor instead of stepper motor because servo motor is more lighter and small weight. So by using, and it also has the same function as the stepper motor, it can control the grip to close and open consistently.
I do agree with your suggestion using servo motor. I think we need to at least put some mechanical stop, which is we can cut the budget using still at the mechanical lab.
I also agree to the Chin point where we use servo motor as a driver for the motor, as driver for the gripper. So may I ask, do you guys have any plan like how do you want to operate the grippers?
Okay, for the grippers, the servo motor will be driven by a motor driver L2930. So the motor will be programmed to clamp the ping pong ball after it being detected by a sensor. Then it will be released at the point B as the coding recommend.
Okay, so talking about the sensors, may I know what type of sensors are we going to use to detect the ping pong balls? And also, I do also have another question where how do we make sure the robot will stop right in front of the ping pong ball and retrieve the balls?
For the type of sensor, I would like to suggest using the ultrasonic sensor and also the infrared sensor as the function for ultrasonic sensor is to measure the distance between points and points, while the infrared sensor is used to detect the ping pong ball. And for the operation, when the robot start moving from point to point, we need the ultrasonic sensor will start operate by sending or receiving the wave, and then measure the distance between points and points. And when it reach some distance, the infrared sensor will start to operate and detect the ping pong ball. And the last part will be the servo motor, which will grip the ping pong ball, and that's how the whole process robot moving. So
I have a question. Why we only use ultrasonic? Why we use
So you means why do we only use ultrasonic sensor in the robot?
yeah.
Yeah, like I said before, the ultrasonic sensor is only used to measure the distance between points and points. But if the robot reaching some points, the robot needs to grip the ping pong ball, right? But before gripping the ping pong ball, the signal it needs some signal to receive and detect the ping pong ball, and we need to apply the infrared sensor to it so that it can detect the light and grip the ping pong ball. That's how the difference for the both components.
Sorry, but in the general, we can use robots component for measuring the distance. Could you explain more about it?
Yeah, that's a good question, but we need to, as in general, as you said before, in general, we can use both components to measure the distance between some points to points, but we need to consider the accuracy for the components. As for the ultrasonic sensors, it receiving and sending back the wave between points, between objects and the objects. So for the accuracy, it will more accurately. But if we're using the infrared sensor, the infrared sensor only reflects the infrared rays from the object. So that means the accuracy for it will be more lower. And so in this project, we would like to using both components to ensure the accuracy, and also by using the ultrasonic sensor, we can prevent the robot from the collision, like collide with the table or something object, some kinds of object.
Okay, I just want to make sure I'm not missing anything. So we're going to use the ultrasonic sensor and also an infrared sensor, right? Okay, so what about the operations of the robots? Do you guys have any plans?
I would suggest to using Tinkercad to run the whole process first for the robot. We can using Tinkercad. And for the coding part, we can do it part by part to avoid make the coding become complex. Like the task needed, the robot move from point B to point A and stop, grab the ball, and then move from point A to backward to the point B, drop the ball, and then move on to the point C to complete the task. After it run it smoothly in the Tinkercad, we can move on to the Arduino to run it in the real life.
Yeah, I agree with Chin Pass, and I also need to, I would like to suggest by include the library, because it will be more easier and for us to manage the whole process and also the whole the coding for inside the robot.
Yeah, I do agree with both of your opinion. Because you use Tinkercad and add on the library to make it smooth and easy to use, right? So what the power supply?
I also suggest using a 9-volt lithium battery for the as the power supply because the motor driver at least needed 9 volt to run. So a 9-volt lithium battery will be the best choice.
I think we have to add switch so that we can manually activate the robots at point B as required by the competition rules.
I also agree with adding a switch where we can manually turn on the robots and turn off the robots because we don't want the robots to keep moving while we are installing or when the competition is not even started. With adding the switch, we can turn on when we need it. So, do you guys have any add-ons or any suggestions?
No?
I do agree.
Okay, before we run into a misunderstanding, let me conclude everything. First, for the body structure, we're going to use a 3D printer. For movement mechanism, we will use 4-wheel driven mechanism. For gripping, we will use a claw shape with a servo motor driven by a motor driver. For sensor, we will use ultrasonic and IR sensor. For the coding, we will use Tinkercad, and for the battery, we will use 9-volt lithium battery. Am I right?
Yes.
Okay.
Yeah,
That's
and,
all.
yeah, and also be able to achieve our aim, which is be able to finalize our robot design by using by includes the parts, and also be able to obey the rules, which is not exceed the dimension and also the budget. Thank you.
Thank you.